Let's talk next about the M in the ADMEs, metabolism. So also note that the A and D absorption distribution are more the two ins. How does a drug get into the body? It's distributed. And then metabolism and excretion is usually more part of how do we get rid of the drug? How do we eliminate the drug? Because the major goal of metabolism is to make the drug more water soluble so that it can be excreted via the kidney. That's where most of our drugs are excreted. It occurs mainly in the liver, the metabolism. And usually it's done in two phases. Phase 1 reactions can happen to the drug. Phase 1 reactions. And those are reactions that give us a metabolite. Could be active, could be inactive, active or inactive. And they are facilitated by so-called cytochrome P450 enzymes. We abbreviate that with CYP450, cytochrome P450 enzymes. There are more than 50,000 identified. The ones that are very important for drug metabolism are CYP3A4, 2D6, CYP2D6, and 2C9. I mean, these are just the most important. There are many more. And this phase 1 reactions usually put some sort of a functional group onto the drug. They're usually responsible for oxidation, reduction, and hydrolysis. And then they can be followed by so-called phase 2 reactions, which usually make this metabolite then more water soluble. So we get some sort of conjugation with, let's say, a glucuronil group or other groups where we just put some endogenous molecules onto this metabolites, and usually these are inactive. And then they can be excreted by the kidney. And if they're not water soluble enough, I mean, some drugs are also excreted via the bile in the feces. But the majority of drugs is excreted in the kidney. So I'm just going to add here, the most famous one is glucuronidation. And here mainly oxidation, hydrolysis, or reductions, which give us this inactive or active metabolite.